Hello everybody and welcome to my presentation. My name is Mounia CHROHO and I'm a PhD student from Morocco, Sultan Moulay Slimane University, Faculty of Sciences and Technology Bni Mellal. My field of research is the biological activities of plants, and the topic of my presentation is comparative study of antibacterial power of four medicinal plants essential oils. I've divided my presentation into 5 main parts. First of all, an introduction. Second, we'll look at the methodology used. Then we'll see the results, followed by a discussion, and finally a conclusion. Let's begin with the introduction, and we start by introducing medicinal and aromatic plants, which are defined simply as plants that are used in traditional and diverse systems of medicine around the world and provide people with medicines and or contain an aroma and flavor. They are used in many domains like medicine, pharmacy, perfumery, agriculture, cosmetology, and others. The importance of medicinal and aromatic plants. The importance of medicinal and aromatic plants return to their optimum contents of bioactive compounds such as alkaloids, terpenoids, phenolic compounds, flavonoids, and tannins, which give them biological powers, antibacterial, antioxidant, and antifungal powers. So they are a promising way to help overcome major problems in public health as antibiotic resistance and oxidative stress. The goal of our research is to study and compare the antibacterial activity of essential oils of 4 medicinal and aromatic plants: Origanum compactum, Thymus zygis, Lavandula pedunculata, and Lavandula angustifolia. Now let's move on to the methodology used. For the plant material, it is originating from Morocco in the northwest of Africa and exactly from the Middle Atlas of Morocco. I'd like to take this chance to show you some natural wealth of this location. It is rich on lakes, waterfalls, in addition of its rich flora, citrus, plants, etc. For the essential oil extraction, the collected samples were dried during 10 days at room temperature in the shade. The extraction of essential oil was made by hydrodistillation in Clevenger device, and the obtained essential oil was stored in darkness at 4 degrees Celsius. For the antibacterial activity, it was tested on 9 pathogenic bacterial strains stemming from hospital: Pseudomonas aeruginosa, 3 strains of Escherichia coli, 2 strains of Staphylococcus aureus, Staphylococcus epidermidis, Proteus, and Klebsiella pneumonia. It was done by 2 steps. First, the susceptibility tests of bacteria to antibiotics, antibiograms, and then the disc diffusion tests of essential oils. Let's turn now to the results. For the essential oil yield, this graph clearly shows that Origanum compactum presented the highest essential oil extraction yield with 3.88%. For the antibacterial activity, we start by presenting the susceptibility test of bacteria to antibiotics, and the results are summarized in the following table, which presents the diameters of inhibition zones of antibiotics. We can see that IPM10 is the most effective antibiotic for 6 bacterial strains over 9, and CIP5 were the effective one on the 3 other strains. In the other hand, we can see that Escherichia coli and Pseudomonas were the most resistant strains. For the antibacterial activity and disk diffusion tests of essential oils, this second table presents the results as diameters of inhibition zones. It clearly shows that Origanum compactum and Thymus digis are the most effective ones, even more effective than the powerful antibiotics, except for Pseudomonas. Moving to discussion part, we notice that Thymus digis and Origanum compactum essential oils presented a remarkable antibacterial activity. These antibacterial effects are closely related to essential oils chemotype and composition, and in the literature, Thymus digis and Origanum compactum essential oils have three main components in different concentration: carvacrol, thymol, and pecimine. And the difference of antibacterial effect on these oils is due to the difference on the percentage of each component and also to the synergy between the components. So that brings me to the end of my presentation. We looked at these three main points. This study shows that the odoricide essential oil of 4 medicinal and aromatic plants collected from Morocco pronounced an antibacterial effect against bacteria. Origanum compactum and Thymus digis presented the highest antibacterial effect, even more than antibiotics. And this antibacterial power is closely related to one of the components, thymol, carvacrol, or pecimine, or to the synergy between the all components. We can conclude that medicinal plants essential oils are promising source of antibacterial components that can help human health, and as a perspective, further studies should be done to the chemical composition of essential oils and inhibitory and bactericidal concentration. Thank you very much.